Today is lesson 107. We are skipping 106 because I want to go over this lesson because I find it really important, especially for going into next year. So this lesson talks about adding and subtracting fractions, and those fractions are going to have common denominators. So that means that they're going to be the same denominator. So as you notice in this picture, or this problem, we have 1/3 plus 1/3. Now, they both have a 3 in the denominator, so that means that we can add it or subtract it as long as it has a common denominator or the same denominator. Okay, so I drew a picture too. We've got 1/3 of a circle and 1/3 of a circle. So if you have 1/3 here and another 1/3, that means you have two of those, right? So that means you have 2/3. So you can now fill in, you had 1/3. You also have another third. So the total amount of thirds are 2 of them. So the answer would be 2/3. Now notice too that your denominator and your answer should also have the same denominator. Okay, I only have this small whiteboard right here. So if you could open up your book and go to page 676. Page 676. And we are going to go over example 1. So I want you to follow along with me. Okay, pause this video if you need to. Example 1. Blake mixed 3/5 of a pound of cashews with 1/5 of a pound of pecans. What is the weight in pounds of the cashew and pecan mixture? Okay, well, we are trying to figure out how much the cashews and pecans weigh all together. So we know that there was 3/5 of a pound of cashews, and then there was 1/5 of a pound of pecans. Okay, we're adding them because they want to know what is the total weight of both of the nuts. Okay, so do we have like denominators here? Are they the same? If they're the same, that means we can just add our numerators up. Okay, so I'm going to draw a picture quick to also help us. Okay, we're going to draw fifths. Okay, so if we have 3 of them, 1, 2, 3, and we have just 1, how many total together are there? Well, the denominator is going to stay the same. Okay, since all of our pieces are in fifths. So then we're just counting how many of those pieces do we have? Well, let's look at the denominator. We have 3 of those pieces and 1 of those pieces. 3 and 1 make 4. So our total for example 1 is 4/5. And to have an answer, they wanted to know what the weight in pounds was. So we would say 4/5 of a pound, or you could just say pound. All right, now, so the same goes for subtracting fractions. As long as your denominator is the same, or if you have a common denominator, okay, you can just subtract the numerators. So to prove that, I have this picture, and I drew this into sevenths, okay, and what I did is I put 5/7 in here, and I kind of colored those in just a little bit. So there's 1, 2, 3, 4, 5/7 filled in. Now I want to subtract 2 of those sevenths, so I'm going to take away 1, 2, and I'm left with 3 of those sevenths. So remember when I said we could do the same thing as adding, so that denominator is going to stay the same. It's going to be a 7. And we can just subtract the numerators then. What's 5 minus 2? 3. And isn't that what happened over here in our picture too? So our answer would be 3/7. Okay, example 2, follow along in your book. To make a small bow for a present, Denitra cut 1/5 of a yard of ribbon from a length of ribbon that was 3/5 of a yard long. What is the length of the ribbon that was not used for the bow? Okay, so we know that she's cutting ribbon. Okay, so if you're cutting something, you're actually taking away from it, so that means we're going to be subtracting here in this word problem. So we know that the length of the ribbon was 3/5 of a yard long. Okay, was 3/5 of a yard long. Denitra cut 1/5 of a yard from that length. So we're going to subtract 1/5 because that's how much she cut. So if we have common denominators here, which we do, they're the same, then all we need to do is subtract the numerators. 3 minus 1 is 2. So we also need a label. They want to know what the length of the ribbon was. So this would be 2/5 of a yard. That would be our answer. 2/5 of a yard. All right, so remember that a mixed number is a number with a whole number and a fraction. So when you're dealing with adding and subtracting with fractions, when you're working with a mixed number, we're just going to add the fractions first, and then we'll add up the whole numbers, okay? So let's go to example 3. Example 3 says add 2 3/5. So that's actually the number I just had written there. 2 3/5 plus 3 1/5. Okay, now we're going to add the fractions first. So these first. So we've got 3/5 and 1/5. So they have common denominators, so we're good. So our answer should have a 5 in our denominator. 3 plus 1, when we look at our numerators, is 4. 3/5 plus 1/5 is 4/5. After you get done adding your fractions, then you can add your whole numbers. So we've got 2 here, and we've got 3. 2 plus 3 is 5. So our total here is 5 and 4/5. That was easy peasy. Okay, in your book, we're looking at example 4. Example 4 says to subtract 5 2/3 minus 1 1/3. Okay, we're going to do the fractions first. Okay, so that would be 2/3 and 1/3. And when you subtract those, since we have common denominators, then you just look at the numerator. 2 minus 1 is 1. So 2/3 minus 1/3 is 1/3. Now we can subtract the whole numbers. 5 minus 1 is 4. So our answer would be 4 and 1/3. Okay, now read with me on example 5. This is our last example. In the race, Martin rode his bike 7 1/2 miles and ran 2 1/2 miles. Altogether, how far did Martin ride his bike and run? So altogether is our key word here. We know that that means that we need to add or multiply. In this case, we're going to add because he didn't have groups of things or groups of miles, groups of anything. So we just want to find his total miles that he ran and biked. So we know that he biked 7 1/2 miles. We're going to add whatever he ran, which was 2 1/2. Okay, when we are adding a mixed number here, we always add the fractions first. So 1/2 plus 1/2, we have common denominators here. So let's look at the numerators. What's 1 plus 1? 1 plus 1 is 2. Okay. And then we can add our whole numbers here. We've got 7 and 2. 7 plus 2 is 9. So we've got 9 and 2 halves. Now something is funky here. This 2 halves can be simplified and renamed into just 1. Okay, now to prove that, if I was drawing halves, okay, and I filled those halves in because there's 2 of them, 1, 2, that makes up a whole circle. So 2 halves, remember if something if both the numerator and the denominator are the same number. That's just one whole. So we've got 9 plus 1, which is 10. So our answer for example 5 is 10.